Everybody, welcome. Thank you so much for coming to our first virtual town hall for the Apache Cassandra community. We're really excited to have you all here. And we still have people coming in. This is really fantastic. We have an awesome lineup of folks today to talk about performance tuning with John Haddad. We have Josh McKenzie here somewhere, I think, here to talk about the 5.0 release update. We have Lorena, Dinesh, and Patrick here to talk about different ways you can participate in the community. So very full agenda, really excited to have everybody here. We wanted to start with just a question. We were planning to do this with a round table, kind of going around asking people, but with so many people, I don't think we'll have the time. But our community question, just to get things going, is what is your favorite dessert? So if you could type in the chat, just what your favorite dessert is, we'd love to see and compare notes and maybe get some ideas on other favorite desserts that we can try. Awesome. I see red velvet cheesecake, Oreo cheesecake, red velvet cake, tiramisu, ice cream and Oreos, espresso. Very nice. Ice cream gelato, lemon tart, multiple cheesecake boats, tres leches, many cheesecake boats, ice cream with Oreo crumbles. Josh says scotch, but maybe aging out of that. Carrot cake or cheesecake, black licorice, excellent. Strawberry shortcake, chocolate cheesecake. Oh, so many. Now, I probably shouldn't have started with a dessert question. For me, it's the morning time, so now I actually want all these desserts. This is great. I appreciate it. We've got, Ras Malai. What's that? That sounds awesome. Chocolate cheesecake, strawberry shortcake. Awesome. Very cool. One of my favorite desserts is sticky toffee pudding cake, if you've ever had that. Although I can't have gluten now, so unfortunately I can't. I got to figure out a way to make it gluten-free. All right, well, let's kind of jump in. This is the first time we've done this town hall. We want to find a time to maximize the ability for people to join. We do have quite a full house on this call, but I would love if you all could take our community poll and just tell us what time slot would be optimal for you. We're going to send this out in other channels too, not just this one, because obviously you're all here. You might choose this time, but we want to understand what time frame works for most people so that we can just, get the majority of people that want to join on this call. So please do take that poll. And without further ado, why don't we turn it over to John Haddad? He is talking today about Cassandra performance tuning like he's been doing it for 10 years. He's very well known for knowing how to do Cassandra really well. We're excited to have him here. John will be presenting. So we will get going with his presentation right now. John, if you need anything else, just let us know. Otherwise, take it.
All right. Thanks, Melissa. Appreciate the intro. So I am John. I've spent around 20 years in tech, 10 of which I've been fortunate enough to work with Cassandra. It's been a ton of fun. So let me just go ahead and share my screen. I'll probably do this wrong. Let's see. Can I be seen and heard?
You're good to go.
All right, awesome. So I got started with Cassandra 10 years ago, working at this startup in Santa Monica, and we had a scalability problem. And they worked with MongoDB and a bunch of other stuff. And I brought in Cassandra, and it turned out to be a great decision. So I got involved in the community and then eventually moved to DataStax, which was kind of a no-brainer if you're really into Cassandra. I spent a few years there working with Patrick and a bunch of other amazing people. Went on to be a consultant at The Last Pickle, which was incredible experience. I got to work on do performance tuning for at least 100 different clusters. Moved on to Apple, where I helped out with the 4.0 release, which is pretty awesome. We built some really cool tooling to help testing there. And then I moved to Netflix. So that's where I just left. Netflix, I did a lot of the performance tuning for the Cassandra clusters, for the biggest clusters that we had, things in the streaming path, things of that nature. And now I'm on my own. So now I'm doing consulting again on my own. So available to help out with people, available to help people do this sort of thing all the time now. Now, when we start talking about performance tuning, one of the most important things is to have a methodology. Otherwise, we're just turning dials and hoping things go right. And randomly picking things and changing them rarely gives us better results. So it's very, very important that we have something that we follow, we stick to it, and it's practical. And I got introduced to this idea while I was at the last pickle. It was invented at the Air Force. It's called the OODA loop. And the OODA loop is designed to basically help you perform well and make tactical decisions in short amounts of time. And so the idea is that we have the first stage, which is observe. Observe, you're basically taking in information. And then orient, and during the orientation phase, that's when you take the information that you've learned and you build a mental model and you try and understand what's really happening in a scenario or in a system. And then you make your decision on what you're going to do, you act on that decision, and then you start the loop over, you go back to observe. And you basically just keep going around the loop until you achieve either the best results you can or satisfactory results. Now, typically, when we start talking about performance, people think of things like dashboards, which are incredibly helpful for understanding kind of a long view of the performance of things. You can see here numbers are going up and down. Very, very helpful, super important. And when things go wrong in a system, we tend to want to also see logs. So the combination of high quality dashboards and logs are what we rely on to get a big picture understanding of the state of a system. But when you start doing performance tuning, you kind of want a little bit more feedback, because in a lot of systems with, let's say, dashboards, you might find that you might have only refresh your metrics every few minutes, or, best case scenario, it's every, let's say, 15, 30 seconds or something like that. So you're not getting real-time information. So I like to rely on command line tools for a handful of reasons. One is I like the real-time aspect. And two, I really like the fact that I'm able to tap into some of the underlying metrics in the Linux kernel in order to understand what's happening with my hardware. And when it comes time to do performance tuning, understanding your hardware is incredibly important. If you don't understand what your hardware is capable of doing, then, and what it is doing, then again, you're just turning random dials. So there's a really, really good technique called the use method. And this was developed by Brendan Gregg. And this is a really great way of understanding any piece of any hardware in your system. And it's also really helpful in understanding like internal software queues. So things like how many requests are coming in can be, you can model that Cassandra side of things, but it's really, really helpful in understanding your hardware. So this stands for utilization, saturation, and error rate. So utilization will be, I'm using, let's say, 50% of my CPU. Saturation is if we've fully utilized the CPU, what's the queue look like? Do we have too much work for the piece of hardware to handle? And is there now a queue behind it? And error rate. Error rate is super important because it doesn't matter if we get really great performance of 1 millisecond for every query. If 100% of them error out, it really doesn't matter at that point. So we need to understand these three things in order to truly know what kind of cost we're seeing on our hardware. Now, before you even get into doing performance tuning, it's a really, really good idea to benchmark your systems and to understand what they're capable of. And this is where I use FIO. So most of the time, or a lot of the time, one of the biggest limiting factors when it comes to a database is going to be your disk, right? And this is true especially for drives that are attached to a network where they might have longer latency. It's spinning Rust is definitely, you want to know what the limits are there. And fortunately, we're not really seeing a lot of that anymore. But solid state drives still have pretty significant limitations. And even when you get into NVMe drives, when they can push 2 gigs a second at 100 microseconds P99 latency, you still have limits there. And I've seen misconfigured servers behave poorly even with NVMe drives installed. So I highly recommend taking a look at FIO before you even pick your hardware or after you pick your hardware to benchmark it. And then that way you can set up your alerts, you can set up thresholds appropriately. So this is what FIO looks like. There's a ton of text on the screen. I hope hope you can read it. The thing that's really important here is that it's a configuration-driven tool. It's pretty easy to use, and you can simulate virtually any workload. So this is actually simulating a bunch of random I/O mixed with a bunch of sequential readers and writers, effectively simulating Cassandra's read operations and compaction at the same time. And so if you take a look here, what you can see is that my writes, I'm doing 27,000 IOPS. My bandwidth is 800 megs a second. And if you look down where it says CLAT percentiles, you can see 99 percentiles, 55 microseconds. So this was on my laptop. It's got an NVMe drive. It's really fast. It's awesome. So I know that my laptop can do all sorts of really cool stuff. I recommend using this if you're going to deploy in the cloud. Very, very helpful to understand what your disks are capable of. So once you know what your disks can do, then you can actually move on to the side of things where you start doing performance tuning. Now, it's really helpful to have a good high-level understanding of what your system is doing at any given moment in time, especially before you start making changes. And this is where I like to rely on tools like MPStat. There's a few other tools that are available that can give you similar information. IOStat is really useful and has a high overlap with this. Even a tool like Top can tell you a lot of the same information. This just happens to be what I like to use because it breaks things out. You can have it break out by CPU, and you can see how much time is being spent in user. Now that's like your Java process. You can see where it's being spent in sys, so that's in the kernel, and you can see where IO wait is happening. So it's nice to see that broken out. If you see a high level of IO wait, then you can determine that your disks are not performing that your disks are a bottleneck. Once you've taken a look at MPStat or these other high-level tools, you might start to ask yourself, what is my database doing? And that's where I'd like to introduce flame graphs. Flame graphs are a really great tool invented by Brendan Gregg that takes sample profiling and mixes that with an incredible visualization that makes it really easy to understand where your time is spent. So if you take a look at the graph right here, as you go up, it's going up the different levels of the software stack that you're running, and the width is a representation of time. So it's very, very easy whenever you open up one of these graphs to get an idea of where your time is being spent because it's just the wide blocks. I've used this to diagnose a lot more than just Cassandra problems. I don't know if any of you have ever been working on someone's come to you with say, hey, the database is really slow. And you look and it doesn't look like it is, and then you profile, and then you look at the application, everybody points to each other. This is a really nice way of getting to the bottom of issues very, very quickly. So highly recommend setting this up and taking frequent profiles with it. Now, I talked a little bit about disk being the problem, and that's what I'm going to focus on for the next few slides here, because I don't have all the time in the world, unfortunately. I'd love to talk more about this stuff. But today we're going to focus on disks because more often than not, it's the root of the problem when you have high latency. And it's the thing that you want to make sure that you tune most appropriately because it's the slowest part of your system. So this slide is talking about BCC tools. BCC tools tap into Linux perf events, which is internal counters in the kernel. And what it does is allows you to very quickly, with low overhead, get a lot of really interesting information out of the kernel about what your system is doing. And so I just stole this diagram from the BCC tool site, but it shows you all of the different things that are available to understand, like the different components of your system. You can look at what's happening on your network. You can look at your file systems. You can look at virtual memory. Everything is available to you. Now, I've worked in a lot of problems where the question has been, where is the performance bottleneck? What do we have to do in order to improve things? And this is where I've heavily relied on in the last few years this tool. It's called bio latency. Stands for block IO latency. And the really cool thing about this is you can run it across one drive or multiple drives, and it outputs something like this. So And you can put in a interval, so it will monitor your drive, or you monitor your drives for some amount of time, and then it will output this histogram. And what's really cool about this is you can see a histogram of the distribution of the request time, and it makes it really obvious like what's going on and where your time is being spent. There's a few other tools like biolatency. There's biolat percentiles, there's biosnoop, there's biotop. So I really recommend taking a look at BCC tools to understand these things. The main goal here, though, is to understand if you see that your latency in Cassandra is at a, let's say it's 10 milliseconds, and you're doing some number of SS tables per read, well, you want to know how expensive is it to actually go to disk? How often is that happening? And by using a tool like biolatency, you can get a very, very good understanding of what's actually happening at the device level. Right? And then we move on. There's another really great tool in this library called XFS Slower. Now, there's a whole bunch of different versions of this tool. There's one for ZFS, there's one for BTRFS, AXT4, like pretty much anything that you can think of, you're going to be able to find a corresponding tool for. The really cool thing about this tool is that it works at the file system level. So I recently worked on a problem where we were concerned about the performance of a file system because the team had network attached storage. And when we ran this, what we found was that we were seeing very, very high latency when the commit log was syncing, but nowhere else. And it was through that we were able to determine that the cost of syncing the commit log was actually the heaviest aspect of what they were doing on the IO side. And that's because the writes, as they were coming through, had to be written to multiple drives, had to be written over the network, and F-syncing on that side. On the other side, we had to wait for that. So, and reads were able to be served at the cache. So it turned out that in this file system, reads were actually quite fast. We never saw them show up in this list, and it was only commit log syncing. So you can pass here an amount of time. So by default, it's going to show you 10 milliseconds. What's really cool about this is it tells you the type of operation, process that did the read, the file, and how big the read was, and the offset in kilobytes, and the latency. So it's an incredibly powerful tool. So if you're curious as to what's taking a long time after you look at biolatency, fire up XFS Slower, and you'll get a much better idea of what's actually taking time on your system. You'll also know how big your reads are, which is really, really important. And then lastly, the third tool that I'm going to talk about today is called cachestat. Now, this is really interesting. So Cassandra, because it relies so heavily on the page cache, it's incredibly helpful to know what your cache is actually doing. And one of the big problems here is, for example, if you're trying to figure out how much memory to allocate to the JVM, one of the things that people will tell you is don't put too much, because you want as much memory to be available to the page cache as possible. Well, cachestat will actually give you a really good understanding of the effectiveness of that cache. So if you increase your memory to the JVM, you can see through cachestat whether or not your page cache hit rate is up or down or the same. So in this case, you can see most of the time our hit ratio is staying the same, and then all of a sudden we have a ton of misses. So this is helpful. I like to give Cassandra quite a bit of memory. I tend to just recommend throwing 30 gigs of memory if you can afford it at it. But a lot of the times that this could come at a cost. So if you had, let's say, 64 gigs of RAM, increasing that memory going from, let's say, 20 to 30, that can take a lot of memory away from page cache. And so if you're not sure whether or not that's the right thing to do because of the negative effects on page cache, this is the way to do it. And you'll get a readout right away. And as the system is running, you'll be able to tell whether or not your page cache is effective. Now, I assume that a few people are here for some easy wins. And I can tell you a couple that are pretty helpful. And I have found that even in pretty much across almost every environment I've ever looked at, these have had an impact and these have been relevant. So the first one is read ahead. And read ahead is a really interesting idea. The idea here is that if we have high latency drives and we do a request, we want to read more than what the original request is. So let's say we ask for 4 bytes off the drive. Read ahead is going to go and by default pull 128K off the drive. Now, that's really helpful when your drives are high latency and the cost to going back and reading continuous tiny bits of data is going to be really slow. But it can be really problematic if you only actually want a little bit of data and you're not doing sequential reads. And this is the case with solid state drives, it's the case with NVMe drives. So a lot of the time, what actually ends up happening is people use the default read ahead on your system. You can go ahead and check it with block dev. It'll be get RA. This is to change read ahead. When it's doing read ahead, it increases what's called read amplification. So what you end up doing is just a ton of throughput on your drive. You end up oversaturating it, and then everything ends up being slow. And I've seen this happen even with NVMe drives, where a team had set their disks to have multi-megabyte read aheads. So every request would do multiple megs of reads, and they fully utilized the NVMe drive, which is kind of crazy. And they were seeing 200 millisecond P99 latency. And fixing this brought our latency down to about 3 milliseconds. So this is a really, really big deal. And on the same idea as talking about read amplification, we have compression. So compression was recently changed in, I'm not sure if it was 4.0 or 4.1, but originally, or for the longest time, compression, which is a table level parameter specified by this flat, the stanza at the bottom here, where it says compression equals chunk length in KB 64. That 64 is the size of the buffer that's filled up with data, compressed and then written to disk along with some metadata. Now, the interesting thing about this is when you need to do a read, you have to get this whole block off disk. You have to do the entire, you have to get all the original data into that 64 kilobyte block. Now imagine a scenario, again, when you're only reading a few bytes or 1K, 100 bytes, something like that, you end up, the read amplification issue hits again, because now you're reading this huge thing off disk and you're only using a tiny bit of it. And so fixing compression, sizing compression to be smaller for read heavy workloads or read before write workloads can show a humongous improvement in performance. And you know, I realize it's you know, just saying read heavy, you might think I don't have a read heavy workload, but there are 2 workloads that are actually read heavy in disguise, and those are lightweight transactions and counters. So in the case where you're using lightweight transactions or counters, if you change your read ahead down to about 4 or 8, depending on the 4 or 8 KB, depending on, you know, what you want to get out of the rest of the system, and then you size your table's compression correctly down to either 4 or 8K, you can actually see a 10x improvement in throughput and latency. All right, and that can translate directly to a 10x reduction in cost for your cluster. So this is a huge deal, and this is something, like I said, I've seen this pretty much everywhere, and every team, no matter how almost every team, no matter how experienced, has had this problem, and it's the easiest thing to tune. I hope you go ahead and try it out and see some improvement on it, because this will it's a total game changer for Cassandra. So hopefully that was helpful. I'll definitely be answering questions in Discord. So please feel free to ask, and I'll turn it back to you, Melissa.
Awesome. Thanks, John. Like John said, he is doing an Ask Me Anything in the Discord right after this call. Diogenes can put the link in here, and we'll share it again at the end of the call, but please do jump over there and ask him questions about performance tuning. Up next, we have Josh McKenzie, who is the chair of the PMC for Cassandra. He's going to talk to us about 4.1 and what is coming in 5.0. Josh, can you unmute, or do you need some help there? We have to give you the powers back. Hang on.
All right. I clicked unmute like 4 times and it was no dice, but now I'm unmuted.
There you go.
goal in life, John, is to grow my hair out and replace your hair that was shorn. And I am making some headway there. So we shall see.
You're
For
looking
those that
great,
don't know,
man.
yeah, John used to iconically have like long hair. And so I'm somehow heading in that direction myself now. So for those of you don't know me, Josh McKenzie, I'm the one that sends out the dev list emails, picked out one yesterday with kind of a summary of what's going on. I take it as a chance to editorialize what's going on with the project and share my little spin and worldview on things, which is exactly what we're doing here today. Interesting how that works. I've been on Cassandra since 2014. I've been in tech longer than I care to think about, but the color of my beard can give you some ideas as to what that looks like. I used to be the lead for Windows support on Cassandra. So for those that like interesting little trivia, and Patrick gave me crap about that for years, as did everyone else. But at this point now I'm swimming in a lot of different waters and tinkering with a lot of different things, as I want to do. So as a snapshot of kind of the state of Cassandra before we get into like the details about 4.1 and 5.0, my opinion is the project's in a really healthy place. It's in a really good place. And one of the things the Apache Foundation is really focused on is diversity and health and longevity of projects, to make sure you have a lot of different contributors from a lot of different places, a lot of different stakeholders, et cetera. So, if one group of people's priorities change, the project itself doesn't, end up stalled or end up, taking a big hit. We're in a really good place. Governance is really active. We just recently passed some changes in terms of bringing on sub projects, and we're kind of looking at how do we bring the ecosystem together and kind of start to simplify and codify some of the things that a lot of people are having to do and lift for themselves. And when you look at the 4.1 release, you'll see a lot of that actually reflected in what came out there, which is how do we make this thing easier to run, right? How do we say, look, there are certain things you can do at small scale that are amazing, and as soon as you try to scale them to large scale, you run into really, really big problems or pain points, or it gets nuanced and subtle in ways you wouldn't expect. And so in 4.1 itself, you'll see a lot of guardrail tickets coming through. Many of those I worked on. Partition deny listing, when partitions get hammered, you can actually help guard them from further usage. Rate limiting, so saying, hey, you know what, don't allow client connections to go past this rate with the native protocol to kind of keep from swamping coordinators. So there's a lot of stuff where it's just like, let's double down on what we do well and help kind of provide a little in project education on what you might want to be wary about and how operators might want to tune that. So, application developers or folks that are accessing the database don't have to know it as deeply. They don't have to take on that whole burden of knowing where all those sharp edges are and generating boatloads of tombstones and detonating themselves, or whatever it may be. So Cassandra as a project, if you look back in its history, we kind of had this lineage of like fail fast. Like if something happens, let the node die. You've got multiple replicas. The other ones will pick up the slack, and that's good until it's not. And there are certain circumstances in which you can end up with cascading failures, other things that make it significantly more challenging to kind of subscribe to that approach to things. And another thing that, this is the too many limes meme, like the first world problem meme for a project. Cassandra's usage grew at a rate that vastly outstripped kind of the expectation of the community for stabilization. And so we ended up with this kind of tension over the years of adding new features in a linear scaling distributed system that nobody's ever done before, and having to come up with novel algorithms, novel features. And oh, by the way, like extricating all the old stuff that came in the guts at the beginning of the project, and we kind of moved away from thrift into CQL, et cetera. So part of what we've seen over the last few years leading up to 4.1 was kind of paying down that debt. The thing that a lot of us as software engineers see in projects where we say, you know what, I know I'm accumulating this burden behind me and I'm dragging it forward and it's slowing me down, and it's hard to be sure that what I'm doing is correct. And at least in my experience, it's not often you see a project that actually succeeds in tackling that, in facing that, and figuring out ways to tighten those things up and clean them up. That was part of the delay that went into 4.0, was that validation and extensive fuzz testing and novel simulation work. That's the focus you see in 4.1. So that's where we get to where we are now. And that's where you get to where you start reading the tea leaves and looking at what's coming in 5.0. And there's kind of a blend between, doubling down on what we're good at and getting further novel and bespoke in Cassandra's linear scale, but also starting to kind of look at the future and say, what actually is possible. A lot of these distributed SQL systems have the notion of partitioning, where within a given partition, you can do a lot of things atomically, but you start crossing partitions and all bets are off. And part of that is because those partitions are stored on different machines. And so you're talking about having an arbitrary number of different machines being involved in some kind of atomic transaction, and things get really messy really fast. So as we come up to 5.0, one of the things a lot of us have talked about and a lot of energy has gone into is a new novel consensus algorithm called Accord. And this uses kind of cutting edge state of the art of a lot of the different things that have happened with the Paxos algorithm over the years, plus some novel insights on top of, I think it was like fast Paxos or some other summations in 2019. So Accord represents an entirely new beast. And we're at a point right now where we have a simulator where we can do deterministic clock testing. We can check to make sure things are actually serializable and correct. We can do things that are very, very novel and have never been done before, and also have the rigorous, effectively mathematical proof that they do what we say they do and that they actually work. And so it's really heartening to me to kind of see that investment pay off, to see that, let's build out this tooling so we can verify what we're doing so we can move fast. We're starting to see the move fast happen. So in 5.0, we also have a new format for the mem tables that's come into the tree that Branimir Lambov worked on. It's a novel data structure that is very, very sympathetic to modern hardware. Has a very interesting take on we all refer to them as trie-based. Technically, I think you pronounce them tree-based, but then everything's a tree and it all gets confusing. But anyway, trie-based mem tables, and there's a massive impact on throughput. So performance is significantly better. Garbage generation is significantly lower. L0 tables, when they get flushed, are significantly larger, so you have less compaction. So there's all these knock-on effects to the improvements in mem tables. That's doubling down on what we already do well. There's hopefully going to be a couple other things that land. One is a new indexing structure for the SS table on disk. What that means to you as operators and as users is faster, better, smaller, less pain on maintenance. And then a third thing that he's got rumbling around, and Jacek and several others, is a new compaction strategy that kind of tries to get the best of all worlds combined and treat compaction differently based on the size and the age, and shards things more intelligently, and kind of opens the path for multi-threaded compaction processing. So there's a lot going on to just make Cassandra better at what it does. And one other thing that we're hoping will land, and it's looking pretty promising, is what we're referring to as transactional metadata, which is strongly consistent metadata, et cetera. You may be familiar with something similar with like etcd and Kubernetes using the Raft algorithm. In our case, in Cassandra, we're doubling down on our strengths, which is linear scale, which is availability, which is be able to treat your database like it's infrastructure software, right? Like, the same kind of trepidation that I hear with Unix administrators that are like, I've got 4 years of uptime, I don't ever want to reboot this. People have that same feeling in their gut about running Cassandra, where it's like, look, this thing has been up and running since pre 2.0. And like, this thing is always up. It is part of our like core infrastructure. So transactional metadata, what that allows us to do is have a much more deterministic view of what the cluster is, to where in theory, you could add or remove more than one node at a time, or hammer that system trying to add 30 nodes at once that all conflict, like some other people are doing with testing, and it's performing admirably with flying colors. So again, it's moving towards this, like, what can we guardrail away, and or what can we change so you don't even have to worry about it or think about it, and have Cassandra just be way, way better at being Cassandra. So Accord, I want to take a minute to speak a little bit more about it. Accord is one of the first times in the last probably half decade I can think of on the project where we're asking the question of like, what is possible? What is the unknown unknown? Like, what would happen if you could have transactions that occurred ideally at, without collision at one round trip across multiple partitions? And if you had that, how would that change your usage of Cassandra? How would that change your feelings about constraint when it comes to your data modeling, when it comes to the size of your partitions, when it comes to what's going on with hotspots? Accord really does represent kind of a paradigm shift in how people using CQL and using Cassandra can think about building their applications, and whether or not you really have to think about data modeling from a Cassandra constrained Cassandra first to a bit more of a flexible and fluid, like logically, what do I actually need, and what do my access patterns look like, and how can I start actually encoding some more relationships into the way that I'm accessing this data, instead of just formally modeling my data based on, how I know I'm going to access it, because that's what I need to scale. So Accord not only kind of opens that door, like it blows the door off the hinges when it comes to looking at your data modeling and what you're going to work with and the different options you have, but it also represents kind of a foundational shift in terms of the primitives that we have to work with. So in the past, one of the things that we struggled with in Cassandra was trying to bake in materialized views, where effectively you would get denormalization server side. And the problems that start to come in with that is what happens when you have data loss, what happens when you have network partitions, and trying to get that right and making sure that you have consistency across what's effectively multiple atomic transactions in two different places, which strangely sounds like exactly what Accord is doing. So there's a lot of things that we can kind of revisit and think about and say, like, what does Accord actually make possible? What is the intersection of Accord with transactional metadata, with these changes in data set sizes, with these changes in compaction? Like, how does it start to shuffle things up with Cassandra to where we can start thinking about tackling some things in a different way that before we always kind of considered, these are things we can't get to. They're just, not options right now. I've got a stopwatch, so I want to be mindful of my time, but there's a few more things that I do want to point out. We've got a boatload of other things in flight. There's a patch around using direct IO for the commit logs and bypassing the kernel page cache. That's got some really, really promising numbers. There's another patch floating around for using direct IO for the read write path. And these are really, really interesting because as John alluded to, he directly stated, like, we rely on the kernel page cache in a lot of ways to make sure that things behave for us. And there's a lot of value, but there's a lot of responsibility in basically YOLOing it, moving away from the kernel page cache and saying, I'm going to handle this myself. But there's an immense amount of potential in that space to get significantly more deterministic behavior out of these systems without some of the pain that we run into now for kind of throwing our hat in the ring with a complex system. Another thing that's floating out there right now is referred to as the Spark bulk writer and Spark bulk reader. Hopefully that will actually land by 5.0, but it depends on when we cut it. That allows you to do massive analytical transactions across your flat SS table files at ridiculous throughput rates. So it really gives people a new way to interact with their data in Cassandra and get it out and put it in that we really haven't had before in kind of a battle-tested, bulletproof way, kind of using tools for what they're really, really good at. There's a fantastic roadmap going forward for 5.1 and beyond, where we've started talking about what things need to live in the node itself, what things might be able to live in the sidecar in terms of maintenance and in terms of being able to elastically scale certain things up and down in the database. Not necessarily like totally drinking the microservices Kool-Aid, mind you, but there is an argument to be made that having certain operations live in the same JVM with other operations, not the best idea. So there's value in exploring that. And then last week we had a really, really fascinating proposal drop about adding a custom, vectorized data format for, large language models, and to be able to do approximate nearest neighbor cosine similarity search on things in a database, which is like really, really, really active and hot right now on the ML side of things. So the idea of having a, petabyte store, linear scale, distributed vector store where you could look things up to feed into a model, like that starts to sound really interesting too. So anyway, Cassandra's a really, really exciting point for me. And I would hope for everybody else in that, we went slow to move fast, and the proof is in the pudding, and things are starting to move really fast. And the trick is to do that and to be confident in what you're doing. And that's where the massive amounts of testing and stabilization and all that come in. So that's kind of like here's your brain dump in 12 minutes and 50 seconds of like the last few years and where we are and where we're going. And yeah, if anybody has any questions, definitely hit me up on Slack or hit me up on Discord in both locations. Definitely excited to talk about all this stuff more. But that's where we're headed. So back to you, Melissa.
Cool. Thanks, Josh. Really appreciate it. Some very exciting new stuff coming in 5.0, as you all heard. If you have questions or want to contribute to any things like this, join the ASF Slack, join the Planet Cassandra Discord. The group is there and happy to answer questions. So now we're going to go to the last section of the town hall. We are talking about ways you can participate in Cassandra. We have a couple people talking about a couple different ways to participate. First up, we have Lorena Poland talking about docs.
Yeah.
I see you there.
Okay. Yeah, here we go.
There you are. All right, over to you.
Hello. I'm always looking for anybody who's interested in docs. It would probably be a good idea to find somebody else to work on that. Unlike the rest of this team, you can see I really do have gray hair, although I've had this for a while. And frankly, a lot of the recent, I won't say only because there are a bunch of people on this call who have also done some work for the docs in the past. I know Haddad in particular has. But recently, it's kind of been a one-person show here. So if you are interested in working on docs, probably the most important thing is that you have to go use the self-service function to get yourself access to the JIRA tickets to start with. Once you do that, some of the component documentation is what you'd be looking for to find tickets that pertain to documentation. And additionally, there's a label called low-hanging fruit. I believe in the notes for this town hall, there'll be a link that would take you directly to that if you have access. Anyway, if you're interested, do those two things, identify something you're interested in, and just reach out to me for some help. I'm more than happy to help people, to mentor folks in the process. We do right now have a little bit tough process for building to look at the work that you do, and I can walk you through that. And yeah, I think that's it. Is there anything else I should have said? Anybody want to speak up?
We have some, there's a couple of links that you shared. We'll put them in the chat so people know where it's in the agenda. So if you're interested in contributing to docs, there's some details in there about how to do that. And we'll put them in the chat now so you can all see them. But I think that's great. I think, as you all know, docs are really important for people using the stuff that others are building. So please do contribute if you can. We would be very grateful.
Yeah, we have a number of things, that could use work. I mean, I think there's some older tickets that are still hanging around for some 4.1, 4.2 topics, as well as the upcoming 5.0 sorts of things. So I'm pretty easy to find, LorenaPoland@gmail.com or Lorena@datasex.com. And yeah, like I said, I'm always interested in building new, documentarians. I've been doing this for a while. So, I really think I'm done.
Maybe we can get Lorena's hair back to a darker color. I don't know if you get some help. Does it reverse? I don't know if it does.
Yeah, just for those of you on the call, my hair started going this color. It started turning white when I was 13 years old. It was this color by the time I was 27. So it's really not the job that's done it to me.
That's good to know. So that's fine. Get into docs. It's help. Your hair won't turn gray if you get into docs. So please help.
I've heard that story a lot, and I think I need proof because I feel like you could just say that. There's no way you could prove that.
Oh yeah, well, the 13 part is kind of hard because they actually airbrushed out my high school pictures. They airbrushed the white out of my pictures, but I can prove the in the 20s stuff pretty easily with a couple of photos. So anyway, if anybody has any questions, reach out to me and ask.
Awesome. Thanks, Lorena. We were going to have Dinesh on next talking about upcoming CEPs, Cassandra enhancement proposals. These are new features and things being considered for Cassandra, but he had to go, unfortunately. He'll probably be at the next town hall meeting, so we can talk to him then about that. So we're going to move next to Patrick McFadden, is going to talk about Planet Cassandra and use cases. Are you unmuted? No, let's get you unmuted. There we go.
I've never had Zoom fight me this hard. This is crazy. It was like, first it was telling me to unmute, and then it wouldn't unmute me. And then, I mean, wow, Zoom sucks. But anyway, this has been our life for years. So So hi everyone. I am so excited. I mean, when I have multiple pages on a Zoom, that's awesome. We have a lot of people here. So now that I have your attention, has anyone been on Planet Cassandra in a while? You should totally go. And here's my dog barking just at the right moment. So we're doing a lot on Planet Cassandra. And when I say we, say hi, Allison, or wave. You can't say anything. Allison works at Inaugural with Rahul and a host of other folks. There's a lot of us that are in the community that are rapidly working on Planet Cassandra to make it awesome for everyone here. So it should be a community resource, meaning that I have some information that I want to get that's not docs. And that's probably the first thing I should say is this is not a replacement for cassandra.apache.org. This is not where you go get documentation. I feel like this is a place where we need to be sharing information about what we're doing. So where the Cassandra site is about, hey, I want to read about the project, get some documentation. What we think of Planet Cassandra and what it has always been is been just like a trading post for information. So if you go there, you should hit refresh and see new information from users all the time. And that's why I'm here to talk about how you can help. Well, there's a few things. I put a link in the chat. These are our use cases that we're collecting quickly here, but use cases are probably the most important thing that you can contribute, because when other people are starting out with Cassandra, or maybe they want to expand their use of Cassandra, what's the first thing you do? You Google it. You're like, oh, well, who else did this? Or maybe you need to be inspired. Like, wow, I never knew that this company was using Cassandra. And, since we're all friends here, it's kind of a cool flex, right? When you look at it and you see like, man, there are so many companies that use Cassandra. Planet Cassandra back in the day, we had over 200 use cases on there. I think it was almost 300 use cases. It's time to rebuild. What's funny is that a lot of those are probably still using Cassandra, and they probably haven't even upgraded their cluster. John, I hope you can talk to them at some point. Those are like 10 years old and they're still running like 2.1. Go team. But your use case is really important. Now, keep in mind, this is a project website. This has been sanctioned by the PMC. This is not owned by any particular company. And the information on here is for the community. And you can share as much as you'd like. When you're on the use case page, if you click on the share my use case, there is a little form there. And here's how you can participate. If you want to just put in a minimum amount of information, like, hey, here's the company that I'm using, the use case, the functional use case, like what it's actually doing, the industry we're in, that's great. That'll publish pretty quickly. If you want to get pretty crazy and maybe do a blog post, go over to the contact page and say, where it says contact us. Someone will be in touch with you, because we would love to help you write up a bigger use case. If you look through the use cases, there's some that are short and some that are super long and detailed. The super long and detailed ones are what get you more points. For what, I have no idea, but more points are good, right? We will be growing this, and we will be thinking about how we can incentivize this activity. Like, people who contribute can get some swag. This is early days, but I'm sure everybody has a use case here, right? If there's other things you want to do, I'm just going to broaden the scope a little bit. If you want to write a blog about maybe how to use Cassandra, like John, for instance, his talk, I'm sure I'm going to convert that into a blog post, John. It'll be pretty awesome, right? Because that's useful information for our community. Also, if you find a link, someone posts a blog post about Cassandra, there's a place where you can just say, hey, I found a link, or I found a YouTube video that's really interesting. Post that. We moderate it through and it goes into the feed. So there's lots of ways to participate, but mostly share the link, tell people about it, because we want people to use Planet Cassandra. I want to see the usage going up, because that means it's now useful. And then finally, if there's anything that you think it should be, go over to the contact us. Tell us. You're a bunch of engineers. I know y'all got opinions. I've seen you on the mailing list. So put them out there. Like, hey, it would be really good for me as a user. I would like to see this information, or maybe something like this. We would, if you could add something like this on here, or this is broken. I mean, we probably got a few of those things, right? Couple, Allison. But that's cool. I mean, this is our site, right? We need it to be what we need it to be. So thank you.
Awesome. Cool. Thanks, Patrick. Appreciate it. And it's planetcassandra.org if you have not visited it yet. And that is the end of our town hall. I just want to mention there's the next upcoming activities. Number one, John is doing the AMA right after this call on Discord. So if you want to ask him some questions, hop on over there, ask him anything. We will have, this is a new monthly virtual event. So the next one is Thursday, May 25th. It might be at this time, but if everybody voted for a different time in that community poll early in the call, then we're going to look at shifting the time to make sure we can maximize attendance. There's a Cassandra marketing working group that happens May 3rd at 8 a.m. There is a link in here we'll put in the chat as well if you want to join that. It's also in the agenda. That's for people to get together to help talk about promoting Cassandra to a wider audience. And then as a reminder, Cassandra Summit is December 12th to the 13th in San Jose. So lots of time to get registered for that. But wanted to keep you all posted of, keep you all up to date on that event as well. Thank you all for joining. We really appreciate it. And if you have a use case or case study you'd like to share, you can get in touch with us via the meetup page, or we're on the ASF Slack or the Cassandra Discord. My name is Melissa Logan. You can find me there. Please reach out and let us know if you'd like to present. Awesome. With that, thanks everybody for joining, and we will see you again next month.